Hey guys, welcome back to my channel. So this is Hardhick.M.Gowda with you today, guys. Guys, today I'm back with another video. So in this video, we are basically going to be studying our class 11 physics, units and measurements. So this is our second chapter. The first chapter, physical world, is completely deleted, and it's not very important topic. It's just the basics in the sense very short note on physics and its types and all. Like physics, we have like types of powers and all it's given, so it's not that important. No questions will be coming. So we are going to be starting with this lesson, units and measurements. So in this video, these are the four topics that we are going to be studying. So those are introduction, physical quantity, units and system of units. So first let us start with an example. So you think that you are going to a shop, okay, grocery shop, where you ask, give me rice of 5. Give me rice of 5. Now the shopkeeper is confused. He'll ask, what 5? 5 can be written as in various forms: 5 centimeter, 5 meter, 5 grams, 5 kilograms, 5 centimeter cube means volume. So he asked, be precise. Precise means just say it correctly. Use the correct quantity. Quantity means the measurement. So now he says, give me rice of 5 kg. Now the shopkeeper understands. Why does he understand? Because he has used the word kg or the kilograms. So this kg acts as a medium of understand, it acts as something that makes the shopkeeper understand that how much quantity does he need. So this is representing the quantity. Okay, this is the representation of a particular quantity. Now, what is this quantity? Quantity is nothing but measurement. So now we have two types of it. Okay, so this was about the introduction. Now let's start. So quantity. So you told, so the first out of quantity, so we have two types: physical and non-physical. So this physical means that those things which can be measured, These non-physical are those which cannot be measured, can't be measured. Now if you ask example, very simple: length, time, area, etc. And if you ask the example of those quantities which cannot be measured, are so many. Write this: laugh, happiness. You say, I'm very happy. That very happy is not said in number, right? Or else you'll not say like, oh, I'm 5% happy, or you'll say I'm 5 happy. No, right? You just say I'm very happy, I'm sad. So these quantities, hunger, these quantities cannot be measured. So once again I'll be saying the quantity is measurement. In this we'll be having two types of: one which can be measured, second which cannot be measured, but we'll say generally like very much. So laugh, happiness, hunger is non-physical, which cannot be measured. Second one is the length, area and time, which these quantities can be measured. Now under these physical quantities we still have classification. So under this physical, I would say these are still classified into two types based on what? So they are classified into two types based on directional properties. Directional properties, so I'll just write directional properties. Means it also includes, these are the measurements that says whether the object is going towards that side or this side, towards you, towards board. It will be saying here, but there is some quantities which doesn't say this direction and all. So these are classified under the directional properties. Those are vectors and scalars. Scalar, vector. Now from the word scalar we can see scale. Scale means measurements. Measurements, like in the sense numbers are there. So scalar, one trick is scalar scale. Scale means only numbers, no direction. This is only magnitude, no direction. Or we have to say that which doesn't follow the vector laws of addition. So this vector law of addition will be studying in the next upcoming lectures, but the vector law of addition, just remember it. Only magnitude, no direction. This scalars. For example, length, area, speed, time, etc. Is time and direction interrelated? No, right? Like time should go in this direction. Okay, that is not there. So those categories or the qualities which doesn't have the directions, those are classified under scalar. So vector, opposite of it, this has both magnitude and direction. This has magnitude as well as direction, and they must follow the vector laws of addition. Understand, this doesn't have to follow, but this has to compulsory follow. Hope you are understanding. Yes. Example, acceleration, momentum, force. So these are the examples that come under vector. Now we have one more classification under physical, that is based on, remember, that is based on dependency. So I'll write one more. This is based on dependency. This is based on directional properties. This is based on dependency. Keep this point in mind. So in dependency means quantity is depending on some other quantities or not. So those quantities are classified here. Those are fundamental, or base quantities, or independent quantities. Independent quantities. This has three names. Remember it. So these quantities basically don't depend on other quantities to define it. For example, centimeter. Does it want any other quantities, for example seconds or temperature, to define this centimeter? That if the particular thing is at this much temperature or it is at this much seconds, it will be 1 centimeter. No, right? Irrespective of its time or the temperature, it will be at 1 centimeter or the centimeter itself, right? So these are called as independent. So those quantities which doesn't depend on other quantities, so these are independent of their own. So these are defined on their own. Example, length, mass, time, temperature, etc. We'll be discussing this after some time. 7 are there, 7 fundamental or base quantities are there, remember this. Next type is the derived. So derived quantity means those quantities which uses one or not one or more, two or more quantities to define itself is called as a derived quantity. For example, force is equals to mass into acceleration. Mass is kg. Acceleration is now by dt by dt. I mean dd by dt. That's different. But remember this, it is having more than one quantity to define it. Okay, hope you understood. Example, speed d by t, right? Kilometer per second, meter per second, sorry. Meter per second. This is using meter and a second, two quantities. These two are fundamental quantities. So this is a derived quantity. So remember this point, very important. So we have now, unfolded the topic of fundamental and derived quantity as well as scalar and vector completely of physical this thing. Now let us go to the next topic. So we have completed our introduction, we have completed our physical quantity. Now let us go to this next, that is units. So what is a unit? Unit is, as I told, it's a representation or the expression of a measurement. Measurement in the sense of fundamental or base or physical, basically physical quantity. Those words that represent or expresses the physical quantities are known as units. So let's erase this and write down the problem. So the unit is basically this expression of measurement. Now the system of units, that is the fourth topic and the final topic of today's one, and we have classification of units, that is a very short topic that we'll be studying next. So now what is system of units? Computer system means including all. System means a component should not be missing from a particular thing. For example, computer system, if CPU is missing, will the computer work? No, right? So if we keep a CPU, that becomes a complete system. System means it will work properly with all the mouse, headphones, speakers, etc. So those environment which has complete everything is called a system, right? So I'll be saying that system of units is complete set. Set means everything in the order wise. Set of all units is called as system of units. That's all. So we used to follow. Now we are very long ancestors were following these three system, but in 1970s in an international meeting these were removed and this system was implied. Okay, next. So what is this system? That is what we are going to learn now. So FPS. So these letters represent some units itself. Unit in the sense like centimeter, meter. This first letter will be of it. So FPS system, it is defining the three basic quantities, that is length, mass and time in this. For length, it is in the same order: length, mass and time. Length, mass and time. Time is constant. Now we are using the same SI quantity, that is second. Next, in length, if we see F, what is F? It's foot or feet. Feet. C, centimeter. Yes. M, general, meter. The second is the mass, that is P, pound, G, gram, and K is kg, that is kilogram, P is pound. Now, what is SI? SI is the international system or international standard units that are used throughout the world, and it is internationally accepted because this was implemented with the international meeting of various scientists when they came together. Okay, so this so we'll say, right, take it in the SI unit or the basic unit, right? So this is what is SI unit. Okay, so what is SI unit? It is international standard or international system. So we have basically 7 quantity. What are those? As I told, 3 general: length, mass, time, temperature, TMP, electric current. Then we have amount of substance, then luminous intensity. Luminous intensity means how much this light is there. Okay, SI unit is meter, kg. Second, temperature is Kelvin, not Celsius, not Fahrenheit. Current, ampere. Amount of substance, mole. Luminous intensity, candela. Representation, general M, kg. For time it is S, Kelvin K, ampere A, MOLE becomes MOL on the candela is CD. Small c, small d. So this was about your system of units. Now let's learn about the classification of units. Now, unit is classified on 2 types basically: fundamental and derived. Same sentence, same meaning from the physical quantity. Those units that are independent are called as fundamental. Those quantities which depend on other units to get its own definition is called as dependent, or you can say the derived units. I'm not going to be saying about it much, but the next one is supplementary units. What are these supplementary units? So some quantities are there which have their own origin and are not included in base quantities and are defined separately in supplementary quantities. So once again I'll be saying, some quantities it is there which have their own origin, means it was found accidentally. It was found, but there's no unit to define it from the fundamental units. So those units were defined separately after the finding of SI units. It's defined separately in the supplementary units. So what are those? Angle. Which angle? 2D. So this is normal. Degree, you'll say wrong. So it's more than degree. This time after this, in 11th and 12th, you will not be using degree much. Everything will be in radians. So remember that it's not going to be easy. Now, this is a circle, center. The angle subtended by 2 radius in the center is called as radian, represented by theta. So if this is radius and this is the element's length of arc from here to there, so that is theta is equals to L by R, or L is equals to theta R. For sure, understood. So this was about the 2D and SI unit. If I take SI unit of this theta, length, L is in length itself, right? I'll take meter only or centimeter. Okay, divided by radius. Radius is also in centimeter itself. It will not be in kg and all, right? It is also length. So I write meter or centimeter. Anything is possible. We will not cancel by centimeter. We'll convert it into centimeter. Then we'll cancel. Make the both units in the numerator and denominator equal. Then we'll be cancelling. So it will be same, right? Now if we cancel this, there's no unit forming here. So that is why we define this unit as radian. So represented by RAD. Hope you have understood. So what is 360 degree? How much is 360 degree? Means this complete angle. Complete angle means the arc is complete. So I'll write theta is equals to R will take R itself, like this one. So complete circle circumference 2 pi R. 2 pi R is equals to R, means this R itself. The same type. R cancel is R. What you'll get? So 360 degree is equals to 2 pi. Now same divided by 2 is 180 degree, right? 360. So 180 degree is equals to pi. This is also divided by 2 only. Now divide it once again by 2. 90 degree pi by 2. Once again divided by 2. 45 degree pi by 4. This is how your radians are expressed. This is the conversion of the angles, degree, from meter to degree. This and how much is 1 radian? 1 radian is equals to 360 divided by 2 pi. If you are thinking how, see, 2 pi radian is equals to 360. Now I can write 2 pi into 1 radian is equals to 360. So 1 radian is equals to 360 divided by 2 pi. Then similarly we'll find out about the degree. So 360 degrees equals to 2 pi radian. Now 360 into 1 degree is equals to 2 pi. 1 degree is equals to 2 pi by 360. So this, make sure you write this down in your notebook, which have written, made a box. One, these two formulas are very, very important. Next is the 2D angle, 3D angle, and the last topic. Hope you have taken a screenshot. Now let's erase it. Angle 3D. So 3D means we have to take sphere. This is a point. Sphere we can't cut like only 2. We have to take 4 radius lines to make a cut and make an angle. So I'll do like this. So this area is there. I'll say it as area A, radius R, and this, as it is 3D, the angle is not measured like this. It's shown the area of it. So that area represented by omega. Okay. So the simple representation is omega is equals to A by R square, because area will be in meter square. So obviously this radius should also be meter square itself. So similarly, area is equals to omega R square. Similarly, SI unit was not found. So this SI unit was kept as steradian. Representation, SR. So hope you have understood till here. Okay, similarly you can find out, your homework or your task is to find out 1 steradian, how much, this one, and 1 degrees how much sterility and all. Okay, hope you have understood all these topics. Next topic will be coming soon. Hope you like my video, subscribe to the channel, hit that bell icon. See you next videos. Bye.